Hello, everyone. I'm your host, Lex Zavala. We are here to talk about our chat, Beyond the Cloud, inside Bitrise Data Center for faster mobile CI. We have RP here, who happens to be our VP of Engineering and Infrastructure here at Bitrise. RP has had his talents in the likes of IBM and Meta, and we're very happy to have him here today to talk about some exciting stuff and a lot of nerdiness to go around and a lot of excitement. And I happen to be a solution architect here at Bitrise. So welcome once again. As Laura mentioned on the chat, please pop any questions for the Q&A later. And we have a lot of content to review, but at the end, we can then go ahead and tackle questions from the Q&A. First off, to start and get the blood flowing, we're going to mention just a little bit about Bitrise and who we are. So we're a mobile-focused DevOps platform. Bitrise streamlines the entire mobile app lifecycle through the platform, from continuous integration and testing and automated deployment, all within a single user-friendly platform. And with our platform, we're really passionate about having leading companies accelerate their release cycles and enable their developers to do their very best work. Now, without further ado, RP, we want to ask you, the main question here is why even build our own data center footprint? Can you tell us a little bit about that?
Absolutely. First of all, hi everyone. Nice to meet you. Hope you have a great time and hope you will enjoy this. So let's go through. We're going to go through a lot of information. So first of all, we at Bitrise, I would like us to think about it as an extension of our customers' teams. So this is important because we are augmenting a big stack for our customers, and we want to be able to serve them as much as possible in a single contact, a single pane of contact posture. So that is the main thing. That is why vertical integration is important. We are going to talk about it a little later. And also, why we built it is having control about the full stack, the network, the metal, the bare metal, the VMs, the virtualization, the switches, routers, everything. And on top of that, the software, we can optimize that. So there's a lot of optimization opportunities. I'm going to address those a few examples as well. So, and what we built is purpose-built for CI workloads. So it's not a generic cloud. It's not something that is off the shelf that people like typically now put together. We really tested everything and built it for CI. We'll address that also. So, and why is this important? So, with the AI, the LLMs, these are getting better and better. The iteration cycle is getting faster and faster. This is at least what we see on our platform from build times and recovery from failed builds. We need a platform that can scale and support this speed increase. So that's something I think is a given. I hope we agree on this. And then, but how do we support this best? In an already proven security posture where the source code, the build environments, the testing environment is already there. So we can bring in AI into these environments and using all the optimization, we can build it out to be the fastest and most efficient, fast and cost efficient both. And then the last one is maybe geopolitical reasons. Recently, this is a big topic. We hear this from a lot of our customers. The data locality is important, not just the cost and control. And where we are right now, we operate in US West and US Central with our data center or co-location footprint, and Europe West is being built as we speak.
Awesome. Thank you so much for touching on those points. There seems to be a lot of reasons and a lot of different angles there. You touched on it a little bit, RP, but can you go a little bit over defining this vertical integrated and hybrid approach? I know there's a philosophy of running wherever the customer runs, essentially meeting them where they're at. Could you expand on that a little bit, please?
Yeah, so vertical integration is multiple things for us. But first of all, again, customer first. We want to run anywhere where our customer wants us to run. So having the stack and having full control, we can take parts of the stack and run wherever our customer wants. So we can run in our Bitrise cloud that we build, or we can run in our customer's cloud account, of course, if the circumstances of that cloud allows, for example, having specific hardware that we need, or we can run on-prem. So we could even drop ship like rack cabinets and run on-prem. So the vertical integration enables us to run anywhere where our customer wants to run. That's one area. And then the other, which is the two major differentiating advantages, that we can optimize, as I mentioned earlier, the massive speed and efficiency. And if something breaks, our customers don't have to find a way to coordinate between 3, 4, 5 different vendors to find and debug the issue. There's a single person or a single contact, and we can pull in the right person, the right expert in that area where we see the problem. And the triage will come later to understand how we do that.
Awesome. Thank you so much, Arpi. And as I know, you're now going to go over the stack and help visualize this for us and the audience. So please proceed with the rest of the slides. We're excited to look at them.
So yeah, so what are the components? So we are going to do a speed run. So hold on to your trousers. We are going to go through very fast what it is, what this looks like. So of course, it starts with network. It's foundation of everything. If that breaks, everything breaks. So obvious. We have except the major types, access, aggregation, edge, that we connect the servers, aggregate the traffic, and then hand off to the internet or to other data centers, etc. These are the major types. What is interesting maybe for the audience is like we chose to go with EVP and VXLAN with ESI legs. This is basically both for capacity and throughput, as well as isolation, and what a customer would typically understand as a VPC in their public cloud. That's basically what it is, with massive throughput and redundancy included. Also, of course, we automate everything, all the provisioning, because as you grow, you can't do that without it. So that's also an important part. Then the next one is in the stack is the infrastructure hosts, Linux and macOS use case. So this is very typical. Not many vendors are out there who are supporting Linux and macOS hybrid. So what we did, we hard benchmarked the hardware, the bare metal, for CI workloads, for compile test, and we chose those specific ones, the specific configuration that is the best. We go and ruthlessly optimize everything. You will see that. And what is also interesting, how do we turn consumer grade hardware into server grade, typically Mac Minis? The housing density and cooling, how does that work? And the remote management. So Linux servers are easy at this point to remote manage. Mac Minis, those are consumer grade hardware, those are not. So let me give you an example how we literally hacked and took over the fan control, the internet fan control of the Mac Minis. This is just one optimization example deep dive, because in half an hour we can't fit more. But so on the screen, you can see that the average frequency for the performance CPU cluster. And if we start hitting the Mac Minis with workload, it will encounter thermal throttling, because the reaction time of the fans and the controller is not as fast as we would like it to be. And it's very good for desktop, but not necessarily if you want to squeeze every single little performance out of the Mac Minis. And what we do with our fan control, you can see there's no thermal throttling. So that is just one area that we are showcasing here, that we go in and ruthlessly optimize everything. And the another is the temperature. So you can see this. I'm not sure if you can see this red line here. That's basically where the thermal throttling will go and kick in. And you can see with the default Mac Mini fan control, it goes typically over. So when we hit it with the workload, it will go over and it will start thermal throttling. With our fan control, you can see it never really reaches. That's why the CPU doesn't enter a thermal throttling phase. So the next one is virtualization. That is mission critical for CI. Of course, as we build the control plane, we wanted to have the same interface for both macOS and Linux, so we don't have to, figure out two different control planes for scheduling and the lifecycle management of the VMs, of the build infrastructure. So we want to have the hypervisor plug and play. The Linux is easy, KVM, battle tested, everyone uses it. It's easy. macOS was a bit more tricky. In the end, we built our own virtualization based on virtualization and then hypervisor framework. We are going further and further down the stack into lower level APIs. Yeah, that's it. Basically, we build something that is pluggable for both, and the control plane can instruct it in the same way. Then the image building. So this is super important. This is one of the things that are probably overseen by people who are trying to build a CI, is how important it is to keep the images or the stacks or the VMs up to date and ready for the next build, with all the tooling updates, the dependencies, security updates, and for example, we are very proud that we are consistently hitting the mark. Once a new Xcode is drops from Apple, within 24 hours we have it deployed at scale on Bitrise, so our customers can start immediately building and testing less than a day after the new Xcode is out. This is important in some use cases where Xcode there's a race to the finish line of Xcode comes out, and you have a very limited time to run tests and then build it with the new Xcode. So that is something that we heavily invested in, and you have to make sure that it's automated, and of course also important for audits and compliance, that it is reproducible and everything is logged. Image distribution. So once you build these images, these can be even hundreds of gigabytes, across multiple data centers. Of course, geo redundancy is important, and we use we take the advantage of the local NVMe, locally attached NVMe SSDs for high speed, for high random I/O output, read and write, and we, of course, when we are distributing, we don't want to overload the network. And also we use BitTorrent for the protocol for distributing, both inside and also across, with some seed servers. So when you are distributing to thousands of nodes or compute nodes, you don't, HTTP wget or a download doesn't really scale. So you want to have something that is scalable, but also have control how fast, how much you overload the network. The noisy neighbor effect is a problem. In my past, there were some maybe in cloud, when someone was deploying and everyone in that zone felt that they could see on the graphs that latency increased. So we want to avoid that, of course. So the next one is the instance management, the control plane. So this is basically just, hey, give me a VM that has this kind of stacks or tools on it, maybe in this network, in this node, or even on that specific host or node, because of maybe dedicated to private customers, etc. So that's the control plane. And what we did here is we have a pre-booting system, a service, that will ask for list, start, stop. Basically, that is managing the full lifecycle. And then we encapsulated Nomad, the open source software, for the signaling. And then we've wrapped that into the control plane, the instance management system, and then between the hosts that are running, starting, stopping the VMs. So basically, that's it. Yeah. The next one is observability. This is super important. One of the most overseen. Like, if something goes wrong, how do you know where it goes wrong, especially in CI, where so many things are going on at the same time? So metrics, traces, logs are all collected, alerts for the on-calls. And what was one of our big breakthrough when we could make these bird's eye view dashboards that have both customer-facing SLOs, service level objectives, that this is what we want the customers to have as an objective, like build time or flakiness, whatever that is. They have a bunch. And then we also have internals that are more aggressive. And then we, of course, alert on the internal already. The dashboard catalog, yes, it's important that you can find very fast and triage. And we, of course, we collect the events in an SQLite and SQL-like database, and we use Metabase also for quick triage when you want to actually write queries. One of the things is that we started doing like a long time ago, but it turns out it was very good investment, is to understand flakiness that we don't necessarily can detect just by monitoring our platform. So we are non-stop building mock applications or open source applications 24/7 non-stop. So even if you have no builds running, we are running builds on our platform just to have a baseline. So we understand that what the baseline is. it helps us to optimize. So we ruthlessly optimize, and if we see the new development, then it should drop the baseline. But also there are some flakiness. A mirror is down, or a mirror or a dependency mirror is slow and stuff. And we need to be able to identify those because our customers are asking, like, why did my build become so slow? Then we have to make sure that we have an ability to triage it, even if it is not our issue, but a dependency outside of our services. Very similar here. We collect the errors, and then we can monitor. We can display them by groups, so we can find patterns very quickly if something goes wrong. This was also super useful. And of course, at the end, CI is on top. And just for the people who are maybe new to the CI, it's super simple. There's a trigger, there's a build request. Hey, I pushed a new code or a PR, and that will go into a queue on our side. And then by that time, hopefully that worker, that stack is already up there that can take the action to build and test the code. And for that, we have the pre-boot of the control plane that we discussed up here, and then of course the autoscaler. So ideally, by the time the request comes, the worker is already there and ready to pick up the job. So that's the CI. And then this is what we have already, and a bunch more. I'll address that. But let's start thinking. Okay, so if we have this in a single stack, same switch fabric, same control plane, like, we have all this automation to build these images. If we put everything together, what else is coming and what is already there? So what is already there? We have the CI, we have a build cache for Bazel and Gradle, and we have remote build execution. So the CI we discussed. Build cache is basically having a build tool like Bazel or Gradle that can separate out things that you already built or tested, and if you change something that is not related to that code, then it can skip that, and you can just build and test those specifics. Of course, you have to prepare your code and your structure in order to support that, but it can be super powerful. So for a 40-50 minute build, time can go down to a couple of minutes, 1 to 4 minutes. It depends on, of course, multiple things. And then another optimization possibility is the remote build execution, where you can slice up certain parts of your build and test, and fan it out to multiple parallel instances, VMs, and then you can further cut down the time. So this is what we already have. This is in production. And then if we think further, what else is coming? What else can we do with this? Again, all the east-west traffic from the build cache to the remote execution or the CI, basically the VMs, is all local, no egress cost, fast, reliable, no flakiness, etc. So it is a purpose-built machine. So the next one is code spaces. So as a developer, you can attach yourself to a code space that runs in our cloud and can take advantage of the local build cache as well as the remote execution if necessary. So this is something that is being worked right now. It's super cool because you have the same environment already set up that is optimized for speed. The tooling is installed, the tooling is constantly updated, etc., already there, so you don't have to worry about it. And you can select between different stacks. You don't have to reinstall your Mac if you want to, or laptop if you want to go up or down, or tooling. Sometimes you cannot do down, expect your next good. So build cache. We can also have remote build cache that you can, if you want to basically develop on your laptop, then you can feed the build cache directly to your laptop from our build cache. And then the next one is, of course, the AI agents. So everyone is talking about this right now, and genuinely, this is now becoming not like a hype. Like there was a lot of hype, in my humble opinion. Some of them is true, some of them maybe not, some of them maybe it's too early. But now we really genuinely see, we use it internally. We have a coding agent that runs in our CI, and it basically can fix not very complicated issues already autonomously. And then basically sends back a commit to the PR with a green build that was read before. So that is something, again, super excited about. We use it internally and comes very soon. The idea is that then you can see this stack. It's basically a purpose-built machine for building, testing, and increasing the iteration speed of developers and the cycle from every angle, and we want to make sure that the experience of the developers is figuring out, focusing on the code and not the CI environment or waiting and going out for coffee or something until my build is running. So keep you in the zone. That's the whole purpose of this stack.
Thank you so much, Arpi. That was a lot to cover, but I really appreciated the breakdown of each individual layer and finally bringing it all together. I'm going to take a quick pause here just to remind folks that there would be a section on the chat for specific Q&A. Feel free to start gearing those up, anything that we've covered or that we haven't covered yet. But without further ado, we're here to now talk a little bit about the biggest win out of all of this. Arpi summarized months and months of work. What is one of the big takeaways, Arpi? I know you wanted kind of like a drum roll moment for this.
Yeah. So look, we are a software company, and it's really fun when you go vertically integrated that you can touch a lot of things. And I genuinely love to nerd out on these things. And what we did is we built something. We built a box. so we literally built a box. So the story behind this is that for approximately 15 years, the Mac Mini form factor didn't change a lot. So more or less the dimensions were the same. Now with the M4 announcement, everything changed. The new form factor is very, very different. And we already had experience running the M2 Pros, and it was we collected a lot of experience how to remote manage them, about the cooling, how the thermal throttling if it happens, etc. So we collected a lot of information, a lot of experience, and then the M4 kind of didn't force us, but it gave us the opportunity to think about it and go one layer down, even to the chassis. Before that, we used off the shelf, like we bought a box from a vendor and put it in and just use it and built around it. But we thought that we can actually go one step further and do this. This basically enables us to have incredibly high density of Mac Mini or any basically small compute infrastructure. It could be Intel NUC or any other, but this is we started with Mac Mini, so that was the use case. And the reason I can announce this, drum roll, I forgot the drum roll, is because yesterday the patent went in. So our patent is pending. We have the priority date, so now we can talk about it and show it to you. I'm excited about this because I never thought I'm gonna do something like this, but it was so much fun. We were joking with the team that who brought what experience from their life to this. I brought that I was playing. My mom asked me constantly to vacuum clean, so I was playing a lot with the vacuum cleaner and airflow and stuff when I was a kid, and I used that experience to visualize at nights for months how the airflow would go through this chassis. Of course, also later I became a private pilot, so I also learned a little bit about aerodynamics, very little, compared to what is required here. But I love just to visualize how air is flowing through or over different surfaces, and we designed that for a team of 5. Basically, the idea is that you can have 32 M4 Pro, any Mac Minis in this chassis. This is 6 units, approximately this high, and you can cool them perfectly. So the cold air comes into the cold aisle and it feeds from the bottom. Typically, the Mac Mini fan intake is like this. If you look at actually I should have added here like a thermal image. Next time. And then the exhaust is here. It goes up, and then it pushes up the hot air. So this is a grill, and then the cold air comes in here, and then we pull up through the cold air through these fans at a high speed. There are strategically located holes at the back, so there is always cold air available because these are 32 individually controlled fans, right? So we want to have that cold air always available for them. And then and then and of course also have here openings to make sure that we can remove the hot air from the top, and then it goes out. So it's like we call it the dual plenum chassis, and then we have, of course, temperature probes, and we can be reactive. But what I'm most excited about is that we can be also proactive. Because of the vertical integration, we know what Mac Minis, what compute nodes are in the same chassis. Therefore, we can schedule the workload strategically if we want to, and then we can preempt the cooling based on either a lookup table that, based on the past, these are the temperatures that we observed, the temperature increases that we observed, and the required fan speed. So we can preempt those, so to further avoid thermal throttling. And of course, also we can use machine learning algorithm to figure out what is the best optimization. This is for CI, of course, we built it for CI, but we could think like, okay, if we run this inference or training or something on Mac Minis, I'm not sure if we ever want to do that, but why not? So who knows where the industry goes? We can basically preempt this, and the control plane, we can preempt the cooling. So we have always enough cold air, and we always remove the hot air from the top. So basically, that's it. I'm super excited, super proud of the team. Vertical integration enables us to ruthlessly optimize at every single layer of the stack. And this is just another thing. There is we are going to show you a link, I think, later, where I suggest to watch, because go and watch that. That's a 1 hour, 60-minute video going through our stack a bit more in detail. This is just a 30 minutes. We can't touch anything, but I wanted to give you some appetite, like how cool things you can build if you go vertically integrated and have your customers optimize not just for speed, but also for cost efficiency. Yeah.
That's awesome, RP. Thank you so much for showing that. It's so cool. I know I geeked out when I first saw it. I recently saw the F1 movie that's in theaters. If there's any F1 fans, and there's some aerodynamics at play that is just the technology behind it and design. Like, it's just truly incredible. And when I first saw that picture, that's the first thing I thought of. Super, super cool. We'll go ahead and wrap up with some takeaways here, and then we do have the additional talk that we'd like to point you to. So some takeaways here. As RP mentioned, this whole system is purpose-built for a CI workload. And a couple things that become very apparent is, even though we summarized it here, building a fully integrated stack is very, very hard, very complex. That to say is, essentially, our philosophy was we earn the battle scars so that you or our customers don't have to. It's an iterative system that supports the iteration, the speed that AI enables. So we talked a little bit about that. Really nice match between CI and AI agents. And because this is, the CI company and the CI platform of Bitrise, this already, by default, working in this vertical integration, it has a proven security posture. It's essentially already something that has been approved by security. The best platform is an extension of your team. This is very important. This is how we do everything we do, and even at the center of this project, it was all there. So, and now that there's some physicality to it, or something tangible, you could say it's a platform team in a box, right? Quite literally. And of course, this tackles a lot of challenges from different angles, but it offers a global coverage. So data locality for cost, speed, and operational resilience.
Awesome. This is the link. Pull out your phone quickly if you want to watch that, or you can just search this, how to build a CI from ground up. It's from our team. We go a deep dive, and then also there is a call to action. We are building a European site for EU West. If you want to register now to stand in line, it's coming hopefully very soon. And one thing, I saw a question from Terry in the chat, how you are securing your AI agents. Oh boy, how much time do we have? Not a lot. So very, very quickly. It's very important, right? there are multiple layers. One is you want to control as much as possible where the AI agents can reach out to the internet if you go YOLO, if you let them do autonomous stuff. So that is an important one. And also, I think most companies, at least from my questions, I see that they are worried about where the inference happens. So what kind of data goes where from my CI environment, which is already proven, it's locked down, we trust it, it is secure, etc. So if you start, there are multiple ways of do inference. We could run on the same hardware where your CI is running, either use GPU or even just CPU. It would be super slow, but it is possible. So just on the same node, on the same hardware, then we could run in the same data center with a GPU cluster, with an inference cluster on the same switch fabric. Then there is a third option, running it in for example, AWS Bedrock's Vertex AI from GCP, that is basically also in your VPC or in our VPC, but the models are in a secure environment, and of course the public available Anthropic, OpenAI, other API endpoints that are able to receive these API requests and do the inference. So the question is really, I think, what we need to figure out as an industry, what kind of data do we trust to go where? And that's what we are working on right now. We are building this the posture, and we break it down. What data do we have? What are the sensitive? What is customer content? And what and the customer has to decide where do they want to run it. And for example, a customer could run their inference on their own API endpoint that either runs in their Vertex AI or Bedrock or similar, or it could run on the public AI hyperscalers at this point. So the AI companies' inference endpoints. I'm not sure if we can go into this later. Hit me up and we can have a chat.
Yeah, RP and myself are both available on LinkedIn. This was really, really cool to go over. We hope the audience really loved it. I was taking a look and just making sure if there was anything else that I saw on the Q&A. I didn't spot anything. I know we were a little over time, but we want to thank everyone that attended. We really enjoyed this time for you. We hope you like the announcement and a lot of the things that we visualized for you. And yeah, don't be a stranger. Please reach out. You have the links in the chat. You have the button here to register for the Bitrice EU data center. Yeah, thank you very much, RP. Thank you so much for your time. This was really, really awesome.
Thank you so much. See you soon. Hope to see you soon.